Hi everyone, in this video I would like to discuss today's LeetCode contest, that is LeetCode Contest Weekly Contest 510. So let's start with the first problem. Our first problem is number of elapsed seconds between two times. So you are given two times, start time and end time. You need to find the number of seconds between these two times, right? So the problem statement is pretty simple and the time format is also given to you: hour, minute, and second. So this is a pretty simple problem, just implementation. So let's implement it, clean code. So first of all, let's implement our function. So let's understand how we are going to implement it, right? So what we will do is, let's try to understand the first. Let's try to understand any sample test case, right? Let's say your start time equals to 10, 14, and 15. Okay, and let's say your end time equals to anything, for example 12, 13, 12. Okay, so how you will implement it, like how you will find the number of seconds between these two times, right? To find that, what you will do is, you will simply increase the start time equals to 11, right? 1 hour that is just greater than equals to the hour of start time. So let's increase start time equals to 11:00:00. Okay, and now you can easily find the number of seconds elapsed between this and this, right? It is easy because our the number of minutes it will take is, so starting from 15, so number of minutes it will take is 60 minus 15, or the number of seconds it will take is into 60, right? And the number of seconds it will take to increase 15 to 60, right? It will be 60 minus 15. Easy. Now these are the number of seconds elapsed between this and this time interval. Now just find the number of seconds elapsed between this and the end time. This is also very easy. Like what you will do is calculate the difference between hour of end time and start time, right? In this case this is 12 minus 11 into 3600, because 1 hour equals 3600 seconds, plus calculate the difference between the minute, right? So let's say you increased 11 to 12. Now the number of minutes, extra minutes you need to elapse to reach end time is 13 into 60, and now the number of seconds you need to elapse is 12. So your total answer is this plus this. So this is how we will implement this solution. So first of all, to make our code very clean, let's implement the helper functions. So let's take the time as input, and this function will give us the integer value of hour corresponding to this time. We will use inbuilt functions of C++ s.substr 0,2. So what does this function give us is, s2i is string to integer, and s.substr 0 to 2, it gives us the substring of length 2 starting from index 0. Okay, and similar thing we will calculate for minute and second. minute starts from third index, right? Because here you can see 0 1 2 3, and similarly your second starts from sixth index. Okay, after implementing these helper functions you can just find the difference similar to this approach. You will first increase start time to the next integer value of hour, and then you can easily find the difference like this. So let's implement the same approach. First of all, let's check if our value of start time, if our value of start time is not equals to our value of end time. In this case we will increase start time to the next integer value, right? And let's also take an integer answer which will store the number of seconds, right? Okay, so if our time of start time and end time is not equal, then we will increase start time to the next integer value of its r. So it will take the number of seconds it will take is, it will take 60 minus minute value of start time minus 1 into 60, right? Because 1 minute equals to 60 seconds, and the second number of seconds it will take is 60 minus second value of start time. Okay, this is good. Now once we have increased r of start time equals to the next integer value, now also calculate the difference from end time. It will be 60 minus r value of start time minus 1. No, actually here it will be r of end time, hour of end time minus hour of start time minus 1 into 3600 plus minute of end time into 60 plus second of end time, right? So this will be our answer for this case when our time is not equals to, our time of start time is not equals to r of end time. In the other case, let's say if minute of start time, do we actually need these loops? I don't think. Else if I don't think we need these loops actually. Okay, let's check. Okay, else if, so other case will be when hour of start time is equals to hour of end time. In this case, let's check if minute value of start time is not equals to minute value of end time. In this case, do the same thing. Increase your minute value to the next integer value. It will take you 60 minus the second value of start time. Okay, and then you will just find the difference from end time. This will be minute value of end time minus minute value of start time minus 1 into 60 plus second value of end time. Other case will be when minute and hour both values are equal but second is not equal. In this case, just find the difference between the second value, second of end time minus second of start time. Let's return our answer. Let's first run it. T, here it is T actually. Okay, first sample test case 25. For second sample test case it is 1504. So let's submit it. Great. So this is how we can implement this solution. Okay, let's move to the next problem. This problem is minimum total cost to process all elements. You are given an integer array nums and an integer k. Initially you have k units of resources. You must process the elements of nums from left to right. To process the ith element you need nums of I resources. If your available resources are less than nums of I, you may perform an operation that increases your available resources by k. The value of k is fixed and does not change throughout the process. The first such operation incurs a cost of 1, the second incurs a cost of 2, and so on. After processing the ith element, your available resources decreases by nums of I. At the end, you need to return an integer denoting minimum total cost required to process all the elements. Okay, problem statement is pretty simple. It is 10 to the power 5, so it is expecting us to solve this problem in linear or n log n time. So let's see how we can solve the first sample test case. Okay, here is our first sample test case. Great. So let's process all of these elements sequentially. Initially, our value of resources is k. Resources, let's say R represents the resources, and initially its value equals to k, that is 4. And let's process it one by one. First, at first index we encounter 1, right? So our resources value will decrease to 1. So resources will remain 4 minus 1 equals to 3. Let's go to second. Resources will remain to 3 minus 2 equals to 1. Let's decrease the resources. 1 minus 3. It's not possible because 3 is greater than 1. So we will have to apply an operation. We will have to apply an operation which will increase our available resources by k. And its cost is, as it is the first operation, its cost will be 1. And in the problem statement is given that the cost of first operation is 1, second is 2. So it means the cost of ith operation is I. So as it is the first operation, its cost is 1 and our resources will be increased by k. So 1 plus 4. Now we have 5 resources and let's decrease 3 from it. The number of resources which remain will be 2. And let's also take cost. Cost will be initially 1 because we have only applied one operation till now. Let's move to the fourth index. its value is 4 and 4 is greater than our number of resources, that is 2. So we will have to apply one more operation on this, which will increase its value by k. So 2 plus 4 and now decrease 4, number of resources will remain 2. And as we have applied operation here, one operation here, increase our cost by 2 because this is the second operation. So our total cost incurred is 3, and this should be our answer for first sample test case. Yes. So how you will implement for a general array nums and value of k. This is also very simple. You will follow the same approach. You will linearly traverse this array nums from left to right, right? In any value of, and let's say it at any index, if you encounter that your nums of I is greater than your resources, then you will increase your resources such that your number of resources is greater than or equals to nums of I, and also keep a track of the cost. So let's implement it. So here, if you notice one thing, if you only know the total number of operations you have applied, then also it is very easy to calculate the cost, right? How is it easy? Because let's say if you know the total number of operations equals to count, right? These are the total number of operations you applied over this array. Then what is the cost? Cost will be simply count into count plus 1 divided by 2. Why is it? It is because for the first operation your cost will be 1, second it will be 2, for third operation it will be 3, up to count. For the last operation your cost will be count. So what is its sum? Its sum is count into count plus 1 by 2, right? You know the sum of first n natural numbers, it is n into n plus 1 by 2. That's what we have done here. So you only need to know the total number of operations you have applied over this array such that all of the resources are consumed by your nums array. So let's iterate this array and let's keep a track of count. Count is actually the number of operations you have applied. And now let's also take r. Initially the resources are equals to k, and let's iterate over nums array, right? If your resources is greater than or equals to u, then what you will do is you will simply decrease your resources. Else case is where your resources is less than u. It means you need to apply some operations. So what number of operations you will have to apply on this value such that your r becomes greater than or equals to u? This will be the number of operations you will have to apply is u minus r plus k minus 1 divided by k minus 1, right? And increase its value in the count array and increase the value of total number of resources, that is operations into k, because in each operation you will increase, this will be k. You understand this thing, right? The total number of operations we need to apply such that your value of r becomes greater than or equals to k. This will be, so let's forget this. Now you understand, right? Total number of operations you need to apply is u minus r divided by k, if and only if u minus r is divisible by k. Now you want to find the next integer value, right? Because your number of resources can't be in decimal, right? You can't apply the decimal number of operations. Let's say you can't apply 2.4 number of resources, 2.3. It the number of operations will always be integer value. So to get the next integer value, you will do this thing. So these are your number of operations you will have to apply. So add it into the count value and increase your number of resources, and now decrease u from r, because the current value u will need u number of resources, so decrease it. At the end also you need to answer modulo 10 to the power 9 plus 7. So let's also define a modulo value 10 to the power 9 plus 7, and also do this thing, take mode of count. Okay, at the end what you need to do is you need to calculate the total cost. Total cost will be count into count plus 1 divided by 2 mod, right? Okay, this is it. Let's take long, because we also need to divide it by 2, and let's not take modulo. At the end we will take the modulo, right? After dividing it by 2, take the modulo. Answer, let's take answer equals to count if answer mod 2, if it is divisible by 2, then do answer divided by 2, else if count mod 2 equals to 0, if it is divisible by 2, then what we will do is return count divided by 2 mod into count plus 1 mod, else return count plus 1 divided by 2 mod into count mod. ओके, आप समझ रहे हो ये चीज़ हमने क्यों करी? आपको ये तो समझ में आ गया होगा टोटल नंबर ऑफ ऑपरेशंस हमने कैसे फाइंड किए, राइट? अब ये चीज़ हमने क्यों करी, आप समझ पा रहे हो? ये चीज़ हमने इसलिए करी क्योंकि हम 2 से डिवाइड भी करना है, हमें वैल्यू क्या निकालनी है, काउंट इंटू काउंट प्लस 1, हमें ये वैल्यू फाइंड करनी है, काउंट इंटू काउंट प्लस 1 बाई 2, एंड काउंट 10 टू पावर 9 से ज़्यादा जा सकता है, राइट? लॉन्ग है। अब ये वैल्यू अगर आप ऐसे ही कैलकुलेट करोगे, डायरेक्ट मल्टीप्लाई कर दोगे, तो ये 10 टू पावर 18 से ज़्यादा चली जाएगी, राइट? एंड यू नो दैट योर लॉन्ग वैल्यू कैन बी एट मैक्स 2 टू द पावर 64 माइनस 1, मीन्स अप्रोक्स अगर मान के चलो तो आप 10 टू पावर 18 तक रखना चाहिए आपको, राइट? सो आपका इंटीजर ओवरफ्लो हो जाएगा, लॉन्ग इंटीजर ओवरफ्लो हो जाएगा इफ़ यू विल डायरेक्टली मल्टीप्लाई दिस. So and you definitely know that either one of these value, either count or count plus 1 is divisible by 2. So to prevent the integer overflow of this multiplication, we have done this if else case, right? First we have checked if count is divisible by 2, then we divide count by 2 and take mode, and then multiply it by count plus 1 and take mode. And similarly, if count plus 1 is divisible by 2, then we divided count plus 1 by 2, right, and took mode of this integer and multiplied it by count and took mode. Right, only multiply after taking mode. So this should work. Let's run the test cases. For first sample test case, our answer is 3. For second sample test case, answer is 15. For third one, answer is 0. Okay, let's submit it. Great. So let's move to the third problem. Here our problem is create grid with exactly k paths. You are given in 3 integers m and k, mn and k. There is a grid m cross n consisting of dot or hash, where dot represents a free cell, hash represents a obstacle cell. A valid path is a sequence of free cells such that it starts at the top left and ends at the top right, and there are only 2 moves, either you move right or either you move down. At the end, you need to return any grid such that there are exactly k valid paths from the top left cell to the bottom right cell. If no such path, if no such grid exists, then you need to return an empty array. Great. So let's see the constraint. M and n are pretty small, that is 1 up to 10, and value of k is also small, that is 4. Okay, so let's try to find all possible cases for this particular problem. Okay, so first of all, understand, like, let's say if value of n equals to 1, right, that means, let's say your n is the value of number of rows, n equals to number of rows in the grid, and m equals to number of columns, right? Now try to understand. Let's say if value of n equals to, first case, if value of n equals to 1, in this case your grid will be something like this. There is only one row, right, and there will be some number of columns. So can you tell me what are the total number of paths can be, right, in this grid? What are the total number of paths that you can produce after replacing each grid cell into either dot or hash? Dot means free cell and hash means obstacle cell. So can you tell me what are the total number of paths you can generate? So here, yes, you can tell me. So there will be exactly one path that is possible from top left corner to the top right corner, right? Because there is no other possibility, and also it is given that k is greater than or equals to 1, so there will be exactly one path. So, and that path will be, you will have to place every cell with dot, that is free cell. Your every cell of this grid should be free cell, and this is only possible when your value of k equals to 1, because there is exactly one path possible. For all other values where k is greater than 1, there is no possible grid, right? There does not exist any grid which satisfies this condition. right? And n equals to 1. Let's take another case where m equals to 1. M equals to 1 is means your number of columns is 1 and there will be several number of rows. This is also very similar case. In this case also you can have exactly one valid path, right, from top left corner to the bottom right corner, right? So there can be exactly one path, and for this, if you have k equals to 1, then you will return this grid where all cells are dot. If you have k greater than 1, in this case you will return empty grid because there is no grid which satisfies this condition where m equals to 1 and k greater than 1, because you cannot have more than one valid path in this grid. So in this case, for k greater than 1, you will just return empty, because in the question itself it is given that if no such grid exists, you need to return empty array. Okay, so these are two cases. Let's understand the third case. Third case is, let's say your value of n equals to 2, m equals to 2. In this case, your grid will be something like this. In this grid, you can have only two paths, right? So you can have a valid grid for k equals to 1, right? For k equals to 1, that is, it has exactly one path, your grid will look like this. For k equals to 2, yes, it is possible, your grid will look like this, right? Because in this case you have this path, in this case you can have two paths, one is this, the other one is this. Okay, for any k greater than 2, you do not have a valid grid, right? There does not exist a grid whose number of rows equals to 2, number of columns equals to 2, and the number of paths can be 3, right? So for k greater than k greater than 2, you will return empty because there does not exist any grid. So let's understand the fourth case. Fourth case is where n equals to 3 and m equals to 2, right? So in this case, okay, so let's say if k equals to 1, right? If k equals to 1, then it is very simple. What you can do is you can just mark these two columns hash and keep all other cells free cell. Okay, and let's say if k equals to 2, then what you will do is, if k equals to 2, then what you will do is you can have, let's say, mark this cell as hash and all other cells as dot free cell. So you have total two number of valid path. Which are those? One is this, another one is this, right? So total two number of paths. Let's say if k equals to 3, it is also possible here. How is it possible? You can keep all the cells free cell. In this case, you have total 3 number of paths. One is this, second is this, third is this. For k equals to 4, it is not possible, right? So you will return empty array. So this was our fourth case. Fifth case is n equals to 2 and m equals to 3. N equals to 2 and m equals to 3. So this is also very similar. 2 3 will be similar to 3 2, right? The only case will be this is a vertical grid, and in this case it will be horizontal grid, right? Like this, right? So you will have the three possibilities. You can have one valid path, exactly two valid paths, and exactly three valid paths. So you can similarly form the grid like this. So we will skip this case now because it is similar to fourth case. The another case is n equals to 3 and m equals to 3. For this particular case, I think you already have a grid. So let's say if you need k equals to 1, this is very simple. What you will do is you will mark first row and last column all free cells. All other cells you will keep hash. Okay, let's assume cross is hash, right? Okay, all other are obstacle cells. Only first column and last row is your free cells. So there is exactly one path. For k equals to 2, what you will do is keep the first column and last row all empty, and also the last second. Okay, let me do this. Okay, also this cell, right, empty. So you will have, in this case you will have exactly two paths, which are those, this one and this one. For k equals to 3, similarly you can find k equals to 3. What you will do is, let's keep these two empty and mark these as closed. So you will see that there are exactly three paths. One is this, second one is this, third one is this. And for k equals to 4, it is already given in this problem, right? So for k equals to 4, you are already given in this sample test case. That is, you will mark these two hash, means obstacles, and all other empty, right? And so this was the case for, so all of the cases are covered in this particular configuration where n equals to 3 and m equals to 3. The seventh case is where either n is greater than 3 और अभी इसको समझना, ये काफ़ी इंटरेस्टिंग केस है. इससे आगे आपको और केस नहीं बनाने पड़ेंगे. either n equals to 3 or either n is greater than 3 or m is greater than 3. अब आपके लिए बहुत ईजी है. अब आप इसको एक ही बार में सोल्व कर दोगे. ये वाला जनरल केस, लेट्स से n is greater than 3, राइट? सो इन दिस केस आप क्या करोगे ना कि लेट्स से m is greater than 3, ये वाला केस ले रहे हैं अभी हम. ओके, और लेट्स से n इक्वल्स टू 2 है ना. अभी आप क्या करोगे ना, लेट्स से k इक्वल्स टू 1 चाहिए आपको. तो आप क्या करोगे, आप इन सारी सेल्स को एम्प्टी रख दो, बाकी जितने ही बचे मतलब इन सारी सेल्स को आप एम्प्टी रख दो, बाकी सबको हैश फिल कर दो, दैट इज ऑब्स्टेकल्स. सो इट विल सेटिस्फाई योर k इक्वल्स टू 1. लेट्स से आप यू वांट k इक्वल्स टू 2. इस केस में आप क्या करोगे, आप इसको फ्री मार्क कर दो और बाकी सबको हैश. इन दिस केस आपका एक और पाथ बन गया, ये वाला. लेट्स से आप k यू नीड k इक्वल्स टू 3. अब आप इसको एम्प्टी रख दो, बाकी सबको हैश, राइट. अब आपका एक और पाथ जनरेट हो गया. और लेट्स से k इक्वल्स टू 4, तो आप इसको एम्प्टी रख दो, तो आपका एक और पाथ जनरेट हो गया. सो यू कैन सी दैट, और बाकी सबको आप हैश रखो. Okay, and you have covered all of the possible cases. So now you can see that if you need any number, so initially for k equals to 1, keep the first column and last row all empty, and the more number of paths you will need, what you will do is you will keep on increasing the number of free cells from last second row, right? So let's say if you need k equals to 2, then you will mark first two cells of last second row empty. If your value of k equals to 3, then you will mark last second row's first three columns empty. If your value of k equals to 4, then you will mark first four cells of last second row empty. All other cells will be hash. Okay, so for this particular case, this is how you can solve this. Do not get afraid by this. Don't get afraid by this total number of cases. If you will see, we will have a pretty nice implementation of this. So let's code it. So basically, you will have to make the number of cases in this problem. There is no escape for this. So let's first see. Actually, swap n and m here, because for understanding this problem, we took n as the number of rows, right? N is the number of rows, m is the number of columns, but here m is the number of rows and n is the number of columns. So swap this to match this solution. And now as we have swapped, our value of n is the number of rows and the value of m is the number of columns. Now just implement these cases, right? So your first case is also define a vector of string grid, right? Initially this is empty, so we will check if n is greater than, if n equals to 1 or m equals to 1, that is our first and second case, where only one exactly one path can be there. So we will return if k equals to 1, then we have a valid grid. What is that valid grid? That is vector of string of n comma string of m comma dot, right? Means all the grid values are free cells. Otherwise, if k is not equals to 1, in that case you will just return an empty grid, right? Because there is no valid grid. Now first two cases are covered here, where n equals to 1 and m equals to 1. Let's cover this case, n equals to 2, m equals to 2. If n equals to 2 and m equals to 2, In this case, there are only two valid paths that can have. If k equals to 1, we will just do this thing. Otherwise, we will do this thing. Right? So instead of this, let's implement the last case first, right? Which is a general case. The general case is where n is greater than 3 or m is greater than 3. If n is greater than 3, if n is greater than 3, means your number of rows are greater than 3, then you will have a grid, vertical grid, not this horizontal grid. So first take an example of this. First take this case, m is greater than 3, so that we can directly relate to this answer. So let's take m is greater than 3. In that case, you will check that first of all, let's assign let's assign n and string of length m and all are filled. Let's assign it here. Okay, so we have filled this grid with all obstacles. Now we will do this thing that for k equals to 1, what you need to have is, for k equals to 1, you need to have the first column and last row all free cells. For int I equals to 0 to I less than n, mark all of the cells in first row, means first column, equals to empty, and mark all of the cells in the last column, in the last row, empty. Okay, this is for k equals to 1. For k equals to 2, we will just mark first two cells of last second row empty. Similarly, for k paths, we will mark first k cells of last second row empty. So do this thing. For int I equals to 0, I less than ki plus plus g of last second row and minus 2 I equals to empty. Okay, so this is our solution for m greater than 3. Else if n is greater than 3, let's also implement the same thing, similar thing. In this case, our grid will be vertical, right? So initially mark all of the cells obstacles. Then what we will do is, in this case, as n is greater than 3, means your grid is vertical. So mark first, mark your first row. So what we will do is mark your first row all empty. Now what if we do this thing? Let's say if our grid is vertical, right? So if our grid is vertical, then mark all of the cells in the first row empty, and now mark all of the cells in the last column empty, right? Now what you will do is you will mark first k cells of m minus 2, means last second column empty. Okay, so this covered the case where n is greater than 3. If if n equals to 3 and m equals to 3, how you will solve this case? If your n equals to 3 and m equals to 3, this case will be this one, right? So just implement it. If k equals to 4, then if k equals to 4, then what you will do is you can just return this grid, right? So this is all values are empty cells except the corner g of 2 comma 0 equals to g of 0 comma 2 equals to empty. Okay, for all other cases what we can do is we can implement it similar to this. We have just understood, right? We will mark the first row and first row, first column and last row empty for k equals to 1, and for k equals to 2 we will mark this empty, and for k equals to 3 we will mark this empty. So just implement it. Okay, so what we have done here is we have marked all of the cells obstacles. Then for first column we have marked all cells empty, and we have marked all cells of last row empty, and then first k empty of last second row. Else case is else if your n equals to 3, your value of n equals to 3, what you will do here? So if your value of n equals to 3, this is this particular case. So here you can have k equals to 1, 2 and 3. So if k equals to 4, then you will just return empty grid. Else, for else case you will do just this thing. What is this? This is just this implementation. Mark first row, must mark first column empty, last row empty, and then first k cells of last second row empty. Great. And return okay. This is good. Now else if else if m equals to 3, what you will do? We'll do the similar thing. If k equals to 4, return empty, otherwise mark all the cells obstacles and mark the first row empty. Okay, and mark the last column empty and mark first k cells of last second column empty. Great, because this is just this is vertical grid. Else cases, the only case which is remaining now is where n equals to 2 and m equals to 2. This particular case where n equals to 2 and m equals to 2. So let's see how we can implement this. So there are only two possible cases where grid exists for k equals to 1 and k equals to 2. Right, so just copy paste above. So for k greater than 2, we will just return empty. Otherwise, we will do the same thing. Mark all cells obstacles, mark first, mark the first column empty, last row empty, and then just first k cells of the last second, that is the first row empty. So this is our solution. At the end, just return this grid. Let's run this. For first one, okay, let's submit it. For n and m equals to 3, we have the wrong answer. Why do we have the wrong answer? For n equals to 3 and m equals to 3, where is this case? This is the one. So for k equals to 4, we had returned this grid where your 2 0 and 0 2 are empty. No, these are hash actually. Okay, let's submit it now. For 3 2 case, output is very strange. 4 3 and 2, it should be this case. It should be this case. M and M. K equals to 3, so all of the cells must be dot. J equals to n comma m. You assigned all of them as hash, and now here what you are doing is you are marking this is very weird. Why is it such? This is very weird output. I don't know why we are encountering this kind of output here. So this case where m equals to 3 means n equals to 3. So this is this particular case, k is equals to 3, so this will go in this else loop. We have assigned n all hash values we have assigned. Okay, now what we have done is, for the last column, no, this is the first, n equals to 3, right? So you have, for n equals to 3, n equals to 3 means your grid will be vertical, right? If your grid is vertical, then assign all of the cells of first column empty. Okay, and assign all of the cells of last row empty. This is also good. For the first k cells, of last second column, assign these to empty. I'm not able to understand why I am having this kind of output. Why is this kind of output I am encountering here? So I have a vertical grid, right? So this should be actually m equals to 3. If your grid is m equals to 3 means your grid is horizontal, right? If your grid is horizontal, in this case, do this thing, what we do, if your grid is horizontal means n equals to 3, m equals to 3. In this case, do this thing, mark the first column and last row empty, and then first k cells of last second row empty. Okay, and this case is n equals to 3. It means your grid is vertical. In this case, you will mark first, in this case you have marked the last row, means the last column empty. Okay, and the first row empty, and first k cells of last second column empty. Now it should work. वो इसलिए आ रहा था क्योंकि इंटीजर आउट ऑफ बाउंड जा रहा था इधर, राइट? हमने वर्टिकल इसको हमें एक्सचेंज करना था एक्चुअली. ये वाली कॉन्फ़िगरेशन आपकी अप्लाइड होगी वर्टिकल के लिए, राइट? और यहाँ पे के जो था, के 3 एस के इज इक्वल्स टू 3 और एन हमारा 2 है, तो इंटीजर आउट ऑफ बाउंड जा रहा था. सो दिस शुड वर्क. Okay, great. So let's move to the fourth problem. Our fourth problem is maximum consistent columns in a grid. So you are given a 2D integer array grid of size m cross n and an integer limit. You may remove 0 or more columns from the grid, but at least one column must remain. The relative order of the remaining columns must be preserved. A grid is consistent if for every row I and for every pair of adjacent remaining columns A and B, where A less than B, the following condition holds. Return the maximum number of columns that can remain such that the resulting grid is consistent. Your N and M are order of 250, 250, right? So let's see how you can solve this problem. So let's say you have a grid, okay? You have this grid. Let's say this value is there are some values in this grid. N equals to, for this particular case, N equals to 3 and M equals to 1 2 3 4 5 6. Okay, now how you will solve this problem? The problem statement is pretty simple. It is saying that you will remove some number of columns, right? Let's say you have removed some number of columns, then after the remaining number of columns, this condition must satisfy. That is, for every two adjacent columns, right, their adjacent values difference must be less than or equals to limit. So here, let's say you removed some number of columns. Let's say you removed this column and this column. After this, the remaining grid will be this. Let's assume that after removing these two columns, right, these columns will be completely removed. Now only your first j equals to 0, 1, 2 is removed. So 3, 4, 4. Okay, this was 0, 1, this was 2, this is 3, this is 4, this is 5. Okay, as 2 and 4th column are removed, so only remaining columns are 0, 1, 3 and 5, right? So this condition must satisfy for these remaining columns. And let's say after removing these two columns, your this condition is satisfied, right? Then your answer will be 4, because you have removed two columns, so remaining total number of columns are 4, and you have to maximize this value, total number of remaining columns, right? So how you will solve this problem? So you can solve this problem with the help of DP. So what you will do is, let's create a DP array of size m, the number of columns, right? And DP of I will store, your DP of I will store the maximum number of columns, maximum number of columns the maximum number of columns left and ith column is also left, and all remaining columns satisfy given condition. Okay, so dp of I represents maximum number of columns left, right, from the first I columns, such that your ith column is also remaining, means you have not removed ith column, and the all of the remaining columns satisfy the given condition in the क्वेश्चन. ये आपकी डिप स्टेट होगी, राइट. नाउ लेट्स सी हाउ यू कैन calculate this dp states, right, how your dp transitions will look like. So first try to solve this problem, right, using this condition. So define a dp array of size m is the number of columns, and this is how your dp state will look like. So first try to think of it like how your dp transitions will look like and how you can solve the final problem. So give it a pause and try to think. If you are not able to think the dp transitions, like how you will actually calculate the dp of I state. So let me help you out here. So dp of I will be actually, you will iterate over the previous left columns. So let's say j is your last column before I, and all columns between these, all columns between j and I, that is j plus 1, j plus 2 up to I minus 1, these all are removed, right, these all columns are removed, right. So, and as all of these columns are removed, now j and I are remaining and these two are adjacent. So you know that as j and I are adjacent now, then all the cells in j and I should satisfy this condition, right. If all the cells, means all the cells in the row, means all the cells in the jth column and ith column satisfy this condition, that is their values difference is less than or equals to limit, then what you will do is you will update your dp transition. How you will update this? Dp of I equals to maximum of dp of I comma dp of j plus 1. आपने ऐसा क्यों किया? ये डीपी ट्रांजिशन क्यों आई इसके लिए? ये डीपी ट्रांजिशन इसलिए आई क्योंकि डीपी ऑफ जे रिप्रेजेंट्स कि जे से पहले कुछ आपने कॉलम्स रिमूव कर दिए थे, राइट, एंड जेथ कॉलम आपका अभी लेफ्ट है, मीन्स यू हैव नॉट रिमूव्ड जेथ कॉलम, एंड नाउ डीपी ऑफ जे represents the maximum number of columns remaining, such that all of the columns before j satisfy the given condition in the problem statement, and now j and I also satisfy this condition, right, we have checked it. So that now j and I are also adjacent and they satisfy this condition. Now it means that we can update this dp of I transition like this, because dp of j represents the maximum number of columns, right, remaining columns, and one is for ith column, right, because our ith column is also remaining. So this is how you can update your dp state, and this is how your dp transitions will look like. So now let's implement this solution. Let's say your n equals to grid of 0, grid dot size, m is your number of columns, and let's take a dp array, dp of m, Now let's iterate over all of the columns of this grid. Here dp of j initially assign it equals to 1. Why I assign dp of j equals to 1? I can do a simple thing. I can remove all of the columns before j. That is j equals to 0, 1, 2, 0, 1, 2, 3 up to j minus 1. So if I remove all of the columns before j, then I do not need to check this condition, right? Because there is no existing column before j. So I can just keep the jth column. So assign dp of j equals to 1. Now iterate over all of the previous columns. Let's say k equals to j minus 1 up to k greater than or equals to 0 and k minus minus. Now what you are saying here is your kth and jth column are remaining and all the columns between k and j are removed, right? So as all the columns between k and j are removed, you need to satisfy this condition. So let's check this condition here. Take a flag f equals to initially true, right? This flag represents that this condition is satisfied. So initially take it as true and iterate over all of the rows, means all of the elements in this column, right? And now check this condition. If the absolute value of grid of I comma j minus grid of I comma k, if this is greater than limit, then what you will do is mark your flag value as false and break this loop, because this condition is not satisfied. And if this condition is satisfied, then update the dp state. How you will update this? Dp of j equals to maximum of dp of j comma dp of k plus 1. Okay, once you have calculated your dp states, what is your answer? Answer is maximum value of all of your dp states, right? Now let's run this solution. For first sample, okay, all are accepted. So let's submit this. Great. So this is how you can solve this problem. It was a pretty easy problem for a DP. Okay, so I hope you understood all of the problem solutions, whatever problem you encountered in any of the problem. So if you still are not able to understand anything in this editorial, you can comment in the video. I will reply. So let's meet you in the next video. Until then, have a nice day. Thank you.